7.26. A. Prove the theorem of perpendicular axis, and B. Prove the theorem of parallel axis. Here in both one hints are given to you. Square of the distance of a point xy in the xy plane from the axis through the origin perpendicular to the plane is x square plus y square. And if the center of mass is chosen to be origin, then sigma mi ri, that is equal to 0. Now suppose here as shown in the figure, this is the planar body. Which one is in xy plane? And z axis, that is perpendicular to the planar body. Okay. Now here O, that is the origin of Cartesian coordinate system. Suppose we consider any ith particle having mass mi, which is at a perpendicular distance ri from the z-axis, then we can write its moment of inertia with respect to z-axis, that is mi ri square. Suppose we consider the body is made by this type of large number of constituent particles. Then for each one, if we calculate the moment of inertia, and then after if we take the summation of all those, then Iz, that is the resultant moment of inertia of the body with respect to z-axis, that is sigma I mi ri square. But from the position of this one, if we draw normals on x and y axis, then using Pythagoras theorem, we can write ri square equal to xi square plus yi square. So here ri square is replaced by xi square plus yi square. So this is equal to sigma I mi xi square plus sigma I mi yi square. So we can write this sigma I mi xi square and this sigma I mi yi square. These two are the moment of inertias of the body with respect to x and y axis. So we can write Iz equal to Ix plus Iy. Perpendicular axis theorem is proved. Now for parallel axis. Suppose here we want to find the moment of inertia of the body with respect to a rotational axis passing through any point, this one. Consider another rotational axis parallel to this first one passing through the center of mass. And here we consider the center of mass, that is at the origin. Arbitrarily we can consider it. Suppose we consider any particle, which one is ith particle with mass equal to mi. It is at a distance ri from the center of mass. So with respect to this rotational axis passing through the center of mass, we can write moment of inertia of this particle is mi ri square. So for such particles, if we calculate the moment of inertias and then if we take the summation for all the particles, we will get moment of inertia with respect to the rotational axis passing through the center of mass, and that we can write Ic equal to sigma I mi ri square. So with respect to this rotational axis, the distance of this ith particle, that is d plus ri. So we can write with respect to this rotational axis, the moment of inertia equal to mi into distance d plus ri whole square. For each and every particle, if we take the moment of inertia and then we take the summation, then I equal to sigma I mi d plus ri whole square. This one d square plus 2d ri plus ri square. Simplify this one. So I, that is sigma I mi d square plus 2d sigma I mi ri plus sigma I mi ri square. But see hint, here it is given to you sigma mi ri equal to 0. So this one is cancelled. So resultantly we will get sigma I mi d square plus sigma I mi ri square. But sigma I mi ri square, that is Ic. Sigma mi, summation of the masses of each and every constituent particle, will give you total mass of the body. So I, that is equal to IC plus MD square parallel axis theorem. Proved. Clear?